press record. Now, the good thing is that we are now well into the semester. So what are we going to cover today? Well, let's take a look. Hopefully all of you have been able to spend some time working on your assignment. As I had said earlier, you want to maximize the marks you get in this assignment before you move forward. I don't think that that as long as you're doing well, you should be able to do well in the second half also. However, having secured some marks, I know when I'm taking a course, I'm really in a better place when I see the marks. I feel a little bit more stable. I feel a little bit more confident. So that's why I encourage you guys to do as good a job as possible. Some of you have already double checked your answers with me. So that was really good. Some of you did the work in class last week. So again, wonderful, amazing to see. And even if you haven't, we do have time. You still have time, a few more days to submit. And thank you to those of you who have already submitted. Now, what are we covering today? Let's see. So we're going to talk about vectors, mostly vectors. So in week 3, it's mostly vectors. I'm hoping to also help you understand the basics of it and then how to create components of vectors, right? What that means is, let's say this is a vector, you can create vertical and horizontal components, which makes it much easier to add, subtract, perform calculations. And assuming, so this, we're probably not going to get to it today because today's only 1 hour. We're going to get into Newton's laws. Remember, I mentioned to you guys how I consider him to be one of the more important people in human history. And the reason is that virtually all construction, it's basically the basis for many of your calculations that you perform. Okay, so another thing I like to do before I start a class is to just go over what are the assessments that need to be done. So I'm probably going to have to change my assignment from the Maple Leafs or Jets blue to Edmonton Oilers colors based on what we're seeing, and remove them from the team of today based on the performances. Unfortunately, turned it off, couldn't watch, turned on the TV when the Oilers were playing though. So as mentioned earlier, assignment 1 is due this week. So next week, I'll hand out assignment number 2. And in a few weeks, we will have our test. It's going to be a little bit interesting because the people who take this course in person, your test will be in class, no big deal. The people who take this online, I do want to watch you writing the test. So I'll offer in a span of about a 12-hour period, 2 or 3 time slots, mostly 2. And then if somebody can't fit those, then we'll figure out a third one so that you can sit down, write the test, and I'll be working on something else, but I'll just want to make sure that you're writing the test on your own. Okay, make sure you have your formula sheets ready for the test. I'm assuming it's going to be, right now I haven't made it, but I think it's going to be based on the first few assignments, assignments 1 and assignment 2. Okay.
Sir,
Yes.
question. Are we still having our meeting on Monday, even though it's Victoria Day?
So that is a great question. I will post a recording for you. So the content will be relevant to this class
Okay.
because I won't be working that day. Um, so I'll post a video for you, and it's going to be a recording. And so I will look much younger and much more handsome. At least I tell myself that. I'll probably have better hair. It'll be from a few years ago. So you'll watch that video and it'll be the same content. But when it talks about, oh, your class, next class, your test, it's not relevant to you because every year it's a little bit different. Okay, so the only
Okay,
thing
thank you, sir.
to focus on is the content, the technical content, if that makes sense. Because yeah, you
Okay,
are correct. Good.
okay,
And now the people who I meet in person, obviously, you might want to have the same thing offered to you, a recording, but we'll talk about that tomorrow because technically you're not off, but we can talk about that. About whether you guys want to take a day off as well and just use a recording. But right now, the people who I meet in person, 701, we will continue to meet in person. The people who I meet online, I will post the recording. I'm hoping to have it posted tomorrow so that you can watch it based on your schedule next week. Okay. All right. Okay. Now, let's see. How do I start this? Looks like I just closed on by mistake. I closed the slides. Now it's always good to have slides, but I don't like to always just work off the slides. Although it does help me in this course for sure. But I'm never one of those people who wants to just watch a lecture based on slides. So I'm going to I'm going to do a little bit of basic discussion today. So I'm probably not going to go based on slides. I'm going to go old school. It's just going to be on a whiteboard. I don't know. I don't know how many other professors use whiteboards at home, but I find it to be incredibly convenient. Okay, so vectors, what are they? They have magnitude and they have direction. Now, I jokingly referred to, knowing which way is north, west, east, south. For the most part, for you guys, the direction you're going to be mostly looking at is upward or downward. Mostly what you're going to be focused on. Although when you get into moments, it's also clockwise and counterclockwise. But for now, it's upwards and downwards. So having that knowledge of north, south, east, west, it doesn't really matter. It's mostly up and down. Now, in the case of when you're talking about components of forces, uh, I mentioned your x component in this direction, you're going to consider to be positive, right? That's why it's important. But if your component is in this a negative direction, or sorry, in the towards my left, it's a negative. And in the case of your y component, in an upward direction, it's positive. In a downward direction, it is negative. Another thing is there is a magnitude, a numerical that how magnitude is like how strong it is, what quantity it is. And you might write it, like for example, if the vector is f, you might write its magnitude like this. But if you want to write it as a vector, you might write it like this. So just to give you guys an example, a real world example, if you have somebody and they're running and then they run back and then they run this way and then they run back, so they may have covered they may have covered a significant distance. Let's say this is maybe they've run 46 meters going back and forth. But if you write this as a vector, that's all they've covered in this direction. That's their end. That's their resultant. And that's why speed is a scalar. It's just, let's say in this say meters per second. But velocity, and sometimes people use them interchangeably, but in physics, they're not really the same. Speed is a scalar. Maybe this is 20 meters per second. But in velocity, it'll be 20 meters per second, let's say, due north. That is the difference. How do you depict vectors? How do you depict vectors? A line and an arrow. And let's say in this case, you just say, let's say it's vector u, it's speed and direction. Sometimes people will have it bold, sometimes people will have an arrow. Now this is the vector. In order to add or subtract with other vectors, I like to have a vertical component, so that would be u, y, and a horizontal component, that would be u, x. Here's where something that we talked about recently comes handy. U y squared plus u x squared is equal to u squared. And let's say this is theta. Sine theta is equal to opposite uy over u. Cosine theta is equal to ux over u. Tangent theta is equal to ux over, sorry, uy over ux. This becomes highly important in the work that we're going to do with vectors. This is going to help you create the calculations that will help you assess your structures. Let's get into the slides proper. We're not going to have a review yet, but we will probably next week. This will probably be pushing into next week. But we'll see how this week goes. So here you've got your displacement. That's got both distance and a direction. So that is where what I was trying to explain comes in. So you've got four blocks, but as long as you say north, then it becomes a vector. You can add different vectors like this. Now in this case, how would you determine the vectors? Right? What you do is you want to split 150 miles, which is at an angle of 20 degrees to the south, or you take it 90 minus 22, that's 68. So it'll be 68 degrees south of east. That's its direction. How do you split it up into its components? So let's go ahead and do that. With the information. It's 150 miles, and we want to split it up into, this is its y component, so we'll just call it y. We'll call this x. We know this angle, it's given 22 degrees. So how do we find x? So sine of x is going to be equal to, oh, sorry, sine of 22 going to be equal to opposite over hypotenuse. This is opposite. Hypotenuse is here, so it's x over 150. Therefore, x is going to be equal to 150 times sine 22. Okay, go ahead and find our calculator. My computer calculator is in the right mode. Make sure it's in, what did I say, degrees, or was it radians? Degrees, right? Yeah, degrees. So 22 sine is 0.374606 equal to 150 times 0.3746. So on 06. So this answer will be times 150, 56.19. So that is your x component. You can do the same to calculate the y component. Y component is going to be equal to 150 times cosine 22. $139.0775. 139.0. I'm just going to leave it as 0.30. 139.08. And that's basically your x component here, 56.19, your y component is 139.08. Another thing you could have done is once you calculated x, to calculate y, all you needed to do was, so y, then it would be y squared plus x squared is equal to 150 squared. That would then be y squared plus 56.19 squared is equal to 150 squared. So y squared would be equal to 150 squared minus 56.19 squared. Let's go ahead and calculate that. 150 times is equal to 22500 minus 56.19 squared. 3157.3161. 22,500 minus 3157.3161. So that should be 19342.68. So y should be equal to 139.077. So there's a few ways to going about this process. See, going back to where were we? So we'll go to this. Oh, are you guys seeing figure 3.7?
Yes.
Okay, perfect. And now, do you see a map of a city?
Yeah.
Yes, Professor.
Okay,
Yes.
perfect. Okay, so I'm on the right page. Okay, so this becomes really important. So let's say if you're looking at a map, how do you navigate? Or if you are presenting a different quadrants and trying to get around. But for you guys, what's pretty much going to happen is you're going to try to resolve vectors into their components to add, and then you get a resultant. And a lot of times we just refer to the resultant as R. So in this case, the resultant is of the addition of A, B, and C. And in the end, what you're doing is you're adding all the X components and adding all the Y components, and whatever the answer is the X and Y component of the resultant. So that's an example here. So Rx squared plus Ry squared is equal to R squared. That's where we're headed, where the Rx and the Ry are the resultant, or components of resultant. So let's go ahead and let's see. Let's go ahead and watch somebody else try to explain the same thing. A couple of clips here that should be helpful. The only thing is sometimes when I share these clips, then the recording becomes copyrighted. So then it can be a bit. So far, students haven't complained, but I just got to be a little bit careful about that when I'm trying to post this to YouTube. Oops, stop share. I need to add the sound.
Hi, I'm Irma. Today we're looking at the resolution of vectors into its components. What do I mean when I resolve a vector into its components? Very often I've got a vector at an angle to the Cartesian plane. I've got my xy axis, and the vector that I've got forms an angle, theta, to either the x-axis or the y-axis. To make my life simpler, it's much easier to take this vector and break it down into two components, a component along the x-axis and a component along the y-axis. How do I do this? We go back to our basic trigonometry. Let's use force as a vector. I'm going to just call that F. The angle between the x-axis and the vector is called theta. I use my basic trigonometry functions to calculate my x component and my y component. If I look at sine theta equals opposite over hypotenuse, and cos theta equals adjacent over hypotenuse, you can see that it's very easy to calculate this component and this component of this force F. Let's look. Sine theta is opposite over hypotenuse. Opposite is my y-axis, divided by my hypotenuse is my F value, and that's going to give me my sine function. If I rearrange my formulas, I'm going to get that y equals F sine theta. The same with my component along the x-axis. X divided by F is adjacent over my hypotenuse side, and that gives me cos theta. When I rearrange these formulas, I get that x equals F cos theta. And by putting in values into F and sine theta, the angle that I've got over there, I can calculate my y component and I can calculate my x component. Thank you very much for listening to this session.
Good video. Let's take a look at another one. That was to help you to how to resolve. Okay, introduction to vectors is another one. Although in this case, I don't think we're going to go that far into it. It's a little bit lengthy, but it gives us some of the, we'll get into some of the basics. Let's see. Looks like my computer is stuck. Did you see an image where you have a vector and vectors and coordinate systems? Do you guys see that? Got an answer here. Thanks, Samira.
It's Professor Dave. I want to.
So do you guys have a favorite professor? I have a favorite professor. His name is Professor Dave. I love Professor Dave.
It's Professor Dave. I want to tell you about vectors.
He knows a lot about all kinds of stuff. Professor Dave explains.
In math, we are always dealing with numbers. Big, small, rational, irrational, but numbers all the same. Now it's time to learn about another concept called a vector. This is a mathematical construct that has both magnitude and direction. The magnitude will be a number, so a vector can have a magnitude of 5. This is the part that tells us how much. But it also has a direction, meaning 5 of something in a particular direction. This is why we represent a vector with an arrow. The length of the vector tells us the magnitude, so a longer vector means a greater magnitude, and the direction the arrow points, relative to some axes, tells us the direction of the vector. Vectors are of tremendous importance in physics because they describe things like forces that cause the three-dimensional motion of objects. You can check out some of the things we can do with vectors after this by checking out my classical physics series. But for now, let's go ahead and learn all the things we need to know about vectors in order to do more math.
I need to find the best way to learn math and science.
It's brilliant.org.
Whoa.
Many vectors are simply displacement vectors, denoting how far an object has traveled and in which direction. If such a vector connects 2 points, like A and B, we can call this vector AB with a little arrow over it. That's one way to represent a vector. We can also just refer to a vector with a letter, like u. Different vectors with the same magnitude and direction are called equivalent vectors. But of course, vectors can have different magnitudes and directions, and we can manipulate and combine vectors in various ways. First, there is vector addition. If we have vector u and vector v, and we place them head to tail, with v starting where u ends, being very careful not to alter the direction of either vector, then the sum of these vectors, or u plus v, will simply go from the start of u to the end of v, forming a triangle, like so. If these vectors were AB and BC, their sum would be called AC.
So this is where we have a challenge. How do we add these vectors? And that's where resolving vectors into their components becomes essential. Okay? So I'm going to show you guys something once we watch a little bit of more of this clip on how we can do that.
As it would connect A and C. We don't necessarily have to draw triangles though. Let's say u and v start at the same point. Let's duplicate u and v and move them so as to form a parallelogram like this. Now the sum of the two vectors, u plus v, can be represented as the diagonal of the parallelogram. So there are a number of ways to represent vector addition geometrically. We can also perform multiplication with vectors. The simplest way to do this is called scalar multiplication. This is when a vector is multiplied by a scalar, which is just a number. So if we have some vector u and we multiply it by the scalar 2, all we do is double the length of the vector, making it start from the same point but reach twice as far in the direction it is pointing. So when multiplying a vector by a scalar that is greater than 0, we just multiply the length of the vector by the scalar. If the scalar is less than 0, or a negative number, we still alter the length of the vector in the same way. But
I don't really get too caught up in the lengths, but this is one method to depict vectors. Okay, so what I'm going to do is I'm going to stop the share, and I'm going to get back into our slides. So you got two vectors, 20 miles and 30 miles. You don't need to resolve them into their components, do you? Why? Because they're already in X and Y direction. What is the resultant going to be of these two? What is the resultant going to be? So easy enough to find. We go back to Pythagorean steps, Pythagoras theorem. So we already know this is 30 miles. This is 20. So the 20 square plus 30 square is going to be 400 plus 900. And that's going to be, let's say this is the result, right? R squared. So what is R squared then equal to? 1300. So what is R going to be equal to? 13, the square root. So that's basically where we're trying to get at. So what you end up doing is, let's say you have a system and you have a bunch of vectors. What you do is, so you're trying to add a bunch of vectors. First, you resolve them into their X and Y components. Then you add all the X components. Then you add all the Y components. And then what you get left with is, so the sum of X components is the X component of the resultant. Similarly, you can say the same thing for y. For the y component. Let's try to go through that. Let's try to go through an example of that here. So let's say you're trying to add, this is 14 newtons. That's the vector. And then you have 100 newtons. And then you have 4 newtons. So let's say this is along the x-axis. We're going to call this vector 3, vector 2, vector 1. Okay, so here's the thing. You're given here that this is 40 degrees. Also, somehow you're given information that this is 20 degrees. And you're given, let me get it closer so it's easier for you to see. And you're given information that this is along the x-axis. So first, what I would do is focus on vector v1. And draw it here. I'm just going to call this the x. So this is going to be v1x. This is in this quadrant, right? So the y component is going to be in the upward direction. v1, we know this is 40 degrees. So what I'm going to do first is I'm going to try to calculate v1x. So v1x is going to be equal to, and we know v1 is equal to 14 newtons. v1x is going to be equal to 14 times sine 40, which is equal to, go ahead and calculate it. 8.999 newtons. v1y is equal to 14 cosine 40 is equal to 10.7246 newtons. So what I would then suggest that you do is write this in a corner. Why? Because you can lose it easily. v1x is equal to 8.999 newtons. v1y is equal to 10.7246. And do that for all of them. For all the vectors. So let's do it for the next vector. For v2, do it in a different color. So that's easy to stay on track. v2 for v2. This is v2, v2x, v2y. 20 degrees. So v2x is going to be equal to v2, which is 100 times sine 20. v2x, therefore, is equal to, so sine 20 times 100, 34.202. v2y, it's in a downward direction, so this is always going to be negative, remember? So it's cosine 20 times 100, and it's in a negative, going to be negative 93.96926 newtons. Now write that somewhere as well. So v2x is equal to 34.202. v2y is equal to minus 93.96. Let's use a different color for our last one. So this is an interesting one. So V3, it's along the x-axis, right? So V3 x is going to be equal to V3. You don't need to resolve it. And V3y is going to be equal to 0. Now, is it negative or positive? It's in this direction, so it's negative. And so what you do is the x component of the resultant is going to be equal to V1x plus V2x plus V3x. We know over here it's 8.99 V1x. Here it's 34, and it's in a downward direction, so this is also a negative. Minus 34.202 minus 4. So that's going to be your x component. And our y is going to be equal to V1y plus V2y plus V3y, which is going to be, so V1y, it's an upward direction, so it'll be 10.724. V2y, it's in a downward direction, it's going to be minus 93.96, and it's 0 for this. So whatever the answer you get, it's going to be the components of the resultant. And then you use that information to calculate the magnitude of the resultant and determine the direction as well. Okay. So let's see. Again, this is so important that you get this. If you don't know how to do this, you're going to struggle in the rest of the course. So we need to watch this again just to make sure you got it.
I don't know, lesson 20. Hey guys, welcome back to another vectors lesson. I'm determined to go through as much of this as possible, so don't be surprised if we get up to, I don't know, lesson 20 or 30 or something like that. So hopefully you guys have been understanding everything that I've been saying. Anytime you feel like you need a bit of help, make sure you let me know via a message or a comment. Okay, so the first thing I want to do today is define a problem. So the question is, consider the vector u, which has a magnitude of 20 and a bearing of 200 degrees true. Express the vector's position in terms of I and j. So basically, we're giving you a vector, but without the x and the y coordinates for I and j, and we want you to find it. So let's draw the vector first. So obviously we're only going to sketch this. So we have the y-axis, the x-axis, and the magnitude is 20 and a bearing of 200. So you can consider this the north. Okay, so it's the north here, and 200 degrees, so we got 90 degrees up to here, and then another 90 degrees up to here, so this is 180 degrees, and then another 20 degrees down here. Okay, so this is 20 degrees, and the magnitude of this vector is 20. So if this is vector u, okay, the magnitude of vector u is 20. Okay, so let's firstly draw our right angle triangle to the horizontal. Okay, so this is our right angle triangle, and let me isolate that triangle by getting rid of everything around it. So I have a right angle here, I have u here, which is 20. Okay, and I'm looking for the y-axis and the x-axis. Okay, so how do we find this? Well, we already know what this angle is, don't we? Right, because theta is 70 degrees. right? Because this angle here is 20, which means this angle here must be 70. Okay, so if this angle is 70 and we want to find y, then we can just use a bit of trigonometry. So this is the opposite side and that's the adjacent side. So and this is the hypotenuse, and using the trigonometry SOHCAHTOA, so you probably need to make sure that you know trigonometry before you do this. So we're using the hypotenuse, finding the opposite, so sine theta equals opposite over hypotenuse. Sine 20 equals opposite over 20. Sorry, not 20. The angle is 70. I should just write 70 here so I don't get confused. So this angle here is 70. Okay. So sine 70 equals opposite over 20. So opposite equals 20 times sine 70. And if you put that in your calculator, and the answer is 18.8 units.
Okay,
18.8 units. So let's do the similar thing with x. So actually I should have substituted y into that equation just so that people don't get mixed up between. So we got y, so y equals 18.8 units. And now we want to find x. So we've got the hypotenuse, we're going to use cosine theta equals a over h. So cos 70 equals x over 20. So x equals 20 cos 70. And the answer is, type that in your calculator. So 20 times cos 70, and the answer is 6.84. Okay, so we have found the x and the y components of this vector. So if we write it as a position vector, we can therefore say vector u is x times I plus y times j. Okay, what's that circle doing there? Let's get rid of that. So therefore vector u is equal to 6.84 I plus 18.8 j. Okay, now does this work for this? No, because the vector is going in this direction. So therefore we need to realize that x is negative and y is negative. So therefore we need to change this to negative 6.84i plus negative 18.8 j. Okay, make sure you get the negative numbers in.
right. Let's end that. We're coming close to the end of the class, so just wanting to reiterate. Should be now getting close to a spot where you can add and subtract vectors, right? And how do you get to that place? You generate the X and Y components. And then you will, in the next step, and we're going to see that in our next class, add, or, as applicable, subtract all X components and all Y components. And then what you're left with is the X component and Y component of resultant. Okay, so that's where we're trying to get to. Okay, now in the next class, what we're going to do is practice a little bit of this. We're going to practice this, and so we'll practice vector additions, vector addition, and then what we'll try to do is get into Newton's laws. That's what we're going to try to complete this week, and that will round off, and we should be doing well by the end of week. That's where we're trying to hit. Okay, all right, so we'll end it there in terms of new content. We will continue in class tomorrow for 701. 401, 402. I will have a video posted for you. I don't think I'll be doing a recording on Monday because it is Victoria Day, but I do want to have the video with the content ready for you. So it'll probably be from a previous year. Okay. So if you guys have any questions for me, you can stick around. I'll stick around for a few more minutes. Those of you who want to head off, you're free to go. I just urge you to attend class or view class regularly. It'll make your life a lot easier. I know in 701, there's a significant number of you who don't come to class. Why? Because I can see you when I'm there in person. And at some stage, it might come back to haunt you. So be careful about that. Unless you're very comfortable with the physics and you think you're going to be fine, then that's you. You're adults. So this is the last time I'm going to bring that up. All right. So I'm going to stop the recording here. And like I said, I'll stick around for a few minutes. The rest of you, if you want to leave, I'll see you tomorrow or the next time.